Thank you for joining my channel, Code IDX. My name is Terrence Whedon, and I appreciate you taking the time to connect with me today. My job is to simplify the learning path so you can achieve your goal of becoming a software developer. So let's get to it, shall we? This is part 2 of this tutorial series on simplifying binary code for beginners. So in part 1, we learned how to count in binary. So if you haven't seen that video, the link is in the description. In part 2, we will learn a little history on why computers can only read binary code, who is credited to encouraging engineers to create the computer, and how to convert decimal numbers to binary and binary numbers to decimals. Allow me to get your mind ready to receive the information I want to teach you by reviewing something you already know and understand. Let's take a look at the decimal system. Notice here we have a table, and the table has 10 rows that's going horizontal and 10 columns that are horizontal, and this is representing base 10. Each column represents a position. So let me get it closer for you so I can see the position that I'm talking about. You notice here, and this is something that we were taught when we were children. We have the column, ones column, the 10 column, the hundreds column, the thousand column. We go up to 10,000, 100,000. You understand how it works because you were taught this when you were younger, when you were in grade school. And one of the things that we learned how to count. We learned that 0 plus 1 is 1. We also learned that 1 plus 1 is 2. But your brain, it doesn't calculate it that way. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't go 0 plus 1 equals 1. 1 plus 1 equals 2. It doesn't work like that, which, let me take that back. It does work like that, but because we understand how it works, we don't have to process it that way. Well, a computer, you have to give it the logic to process it properly. And a computer can only read binary code. But notice something else that you're doing here that I want to introduce to you to get you prepared for the future. You're actually looping through each one of those numbers. You're incrementing by 1. Every time you go to the next whole number, you're incrementing by 1. Well, that's what a loop is. It loops and it increments. And we'll teach you that in later lessons. But for now, I just want to get your mind prepared for it by showing you something that you already been learned. Understand something here. A computer has to be told what to do. It has to be given the logic. Well, we didn't come into this world knowing everything. We had to be taught as well. And you were taught these concepts in kindergarten or preschool. And because you've done it so much, you don't even think about it. You just know how to increment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because you've been doing it all your life. Well, a computer, it moves very quickly once you give it the correct logic. So here, as we look at this table, we understand that in our minds, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But really in our brains, it's calculating each a digit. It's going 0 plus 1 is 1. 1 plus 1 is 2. And when it gets to the 9, and we go 9 plus 1, our brain automatically tells us it's calculating it to be 10. But it knows that it's adding that 1, or it's resetting it back to 0, and it's adding the 1 to the next column. It's looping to the next column. And that's how computer programming works. That's how the compiler does it. And it takes those numbers and it converts it to binary code. So now we understand how this process works. Now let's begin to apply it to our binary code system, right? So here, what I have here is basically a little table again. Notice here, I have some numbers. I have some numbers at the top. 1, 2, 4, 8, 16, 32, 64, 128. Well, let me take you back, a step back a moment. Each one of these numbers represent a bit. Every 0 and 1, each one of these are considered bits. A 0 is a bit, 1 is a bit. This 1 at the top of this box is a bit. This 2 at the top of this box is 2 bits. This 4 is 4 bits. And you notice that I have 8 boxes. Oh, let me pull that back up. You notice that I have 8 boxes. 8 bits represents, let me put the 8 bits equal, yeah, in this case I can say equals 1 byte. Now, let me explain something else to you that you need to understand. The number 0 in binary, it starts with 0. The highest number in binary is 255. This is the binary code for 0. Notice here, I'm filling in this box with 8 zeros. In a moment, I'm going to explain what those numbers at the top do. Now remember, this equal sign is not an equal sign in computer programming. It's an assignment operator. So 0 is assigned to this byte of code or byte of binary code. 255 is the highest and is represented with all ones. So when you see all ones, 8 ones, which is 1 byte, which is 8 bits, it is assigned to 255, or 255 is assigned to all 8 of these ones. Now let me show you a table, introduce this table to you, this binary table. You notice right here, it has the number 255, which has 11111, like I was saying, and 0. And in between, it has a binary code all the way up to 255. Why is this significant? Because this 255 number means that we have 255 bytes, and they're all assigned to something. All right, let me help you visualize this a little bit. You have your keyboard in front of you, and you notice that your keyboard has a lot of keys. Now, this is a sidebar. And now, when the computer was created, the first thing that they wanted to do was to program the computer to count. Well, in order for a computer to work, it can only read binary code, and those binary codes come from what we call micro switches. They have electric going to them, and they only have on and off, on and off, and it has 1 byte, 8 bits. These numbers again they mean something, and I get to that for a moment. So in order for something to be on, it has to have 1. So 1 represents on, 0 represents off. How they came up with that, it came from a mathematician. His name was George Boole. I will teach you in later lessons about Boolean. Boolean in every programming language is a primitive data type, and it means true or false. Well, George Boole wrote algorithms to prove if something was true or false. So you have true, and then you have false. 0 represents false, 1 represents true. 0 represents off, 1 represents on. So get your head around this. Now, how do we get to this 255? Like I said, these numbers here, 128, 64, 32, 16, 8, 4, 2, and 1. These are bits. And how we get there, I'm going to show you how we convert these numbers. So I'm going to pull up a calculator here. Now I have this calculator, and what I want to do is I want to be able to, let me move this over so I guess this is the best because I don't want to move it over just a little bit. I want to subtract these numbers from this number right here. So the number is 255, so let me put 255 over here. So I'm going to move this so you can see it. I want to minus 128. Can 128, can you subtract 128 from 255? Yes, you can. So that means that's true. It gets a 1. So let me move it up so you get the 1, right? So the next one is 64. Can I subtract 64 from 127? So 64 minus 127, which is yes, which is true. I get another 1. Can I subtract 32 from 63? So I'll subtract 32. The answer is yes, which is true. I get another 1. Can I subtract 16 from 31? So let's see, 16 minus 31. True. So I add another 1. Can I subtract 8 from 15? 8 minus 15, which is true. I add a 1. Can I subtract 4 from 7? Add a 4. Let me subtract a 4. I get 3. Can I subtract 2 from 3? I get 1, which is a true. Another 1. Can I subtract 1 from 1? Yes. That's how we came up with the binary code 111. These numbers represent something. And we're going to use them the same way that we use to create the numbers or to create the binary from a number or convert the binary by convert the number or the decimal number to binary. I'm going to show you how to convert letters into binary. So I'm going to introduce another table to you right now. And this is the ASCII table, which stands for American Standard Code for Information Interchange. If you notice here, we have something that's called the DEC, which is the numbers, and that number is assigned to these different characters. Now, these are not actual numbers, these are actual characters, because we were saying, well, 0 is supposed to be 0. No, 0 is null. But this is a character, and this is based off of your keyboard if you look at and pay attention to what's there. So if I go down here to this other particular table, it shows you the binary code as well, and also the HTML code. This is something that you're going to get familiar with as we go into later lessons. But take a moment to read this, and this is going to help you understand a little bit more how these characters work. Now, what I want to do now is I want to go back to my board, and I'm going to go to the converting chart. Now, one of the things I want to show you is the capital A. Let's show you capital A. We'll start there. Notice here we have a number assigned to capital A, which is 65. The lowercase a is 97, two totally different numbers. So that number assigned to A, I can convert this number 65 to binary. Now, computers are universal. They read binary code. All of our languages are different. We use different symbols in different languages. So these codes, binary codes, or these numbers, which is 255, is well more than enough to represent all of these characters so that we can convert it to binary code. So 65 is assigned to A. So A is assigned to 65. So let me go over here. So I have the capital A, and I'm going to give it the number 65. So now that I showed you how to convert, 65 is assigned to this binary number. So the question is, can I subtract 128 from 65? No, I can't. So that's false. So let me give a 0. Up that looks like a Q. So let me erase that. All right, let me get back over into my pen. So that's a 0. Can we subtract 64 from 65? True. I give it as 1. So it's only 1 left. So I cannot subtract 32 from 1, which is a 0, which is false. 16 is false. 8 is false. 4 is false. 2 is false. 1 is true. So that's the binary code right there. How do I get 65? I just add the ones back up. That's how you know what the binary code is. So if I go over here and then I want to write another number, so let's say if I want to do B, I know B is 66. So I know I want to add the 64. I know that 32 and 64 is not going to give me a 66. But I know that this 2, oh, let me put that right there. Let me erase that because that looks like, doesn't look like a 1. So, all right. So now, if I add these two numbers up, 64 plus 2, I get 66. I know that's a capital B. Now, this is how you convert binary to a number. This is how you convert a number to binary. This is how you convert letters and symbols to numbers. You have to go to the ASCII table, find out what the number that's assigned to that symbol, and then we convert that number to binary. Now, just to give you a little more understanding, your keyboard, remember micro switches. To get a capital A, I have to hit the caps lock or the shift button. Well, the computer is sending a signal to the compiler to let me know that there's a number assigned to that shift button, to that caps lock button, and then whatever other key I hit, there's a number assigned to that as well. So that when I hit the letter A with the shift, it's telling the compiler, inputting information to the computer system, saying that that is number 65. Number 65 is assigned to this particular binary number. Now, in the next video, I'm going to show you how that is allocated in memory. All of this goes together. There's no magic happening behind the scenes. It's all logic. So, I hope that this video was very helpful to you. Bookmark this. This is important that you bookmark these videos because so you can come back later and use them for references. Also, too, if you haven't subscribed, subscribe to the channel. Share this video with your friends and family, anyone that wants to change their career. Maybe someone has a business and they need an app created. They can't afford someone to create the app for them. Or if they can afford it, at least they can learn how the process works. So when they're interviewing someone to do the work for them, they can articulate themselves so they don't have to spend as much money. Because if you don't know how to articulate yourself to a computer programmer, it can get very expensive because it takes time to create software. Also, like the video and share the video. And I'm going to go out and make the next video and I'm going to upload that. That's going to be part 3. And we're going to go over how this is allocated in memory. I thank you again for taking the time to listen to the video. These videos are a little bit long and I understand, but it's so much information that I need to give to you. And it's a process. Respect the process. But that's why I say bookmark these videos. So I hope you enjoyed this and happy coding.